Now we have the rate of change. So I had told you in the last section there that I didn't like that there was no amount of time on the bottom. And that's because, for this question here, we didn't really know how far away from this detector were we walking and how long did that take. And so now these questions moving forward, we're going to have a little bit more information. And if we have some more information, we can actually calculate how steep something is. So are we moving quick or are we moving slow? So how quickly or how slowly? And that's called your rate of change. How quickly are we changing, or what is the rate at which we are changing? And to calculate that, we had to come up with a system. As mathematicians, we all wanted to write this the same way so we could compare how fast or how slowly we were moving, or how our rate of change was. And so we decided, and I say we, but I wasn't part of the conversation. We decided that it's called delta y over delta x. And delta, you just drew a triangle. So triangle y over triangle x. But we say delta y over delta x, and you can write that down and then immediately forget that. What we are looking for is our change in height divided by our change in, change in, I guess, length. So we're looking at the change of our y over the change of our x. And we could have decided, let's do the change in length over the change in height. We could have flipped it around. But someone a long time ago decided, no, we're always going to do the change of our y divided by a change of our x, and then we can compare answers. Now we did decide on maybe a little bit different language, and we said, well, let's not use the word height anymore. Let's do our change in our rise. How much do we rise up and rise down? And then instead of doing the length, let's call that how much we run. Are we going to the right, going to the left? We're running left or right. And so that's why you'll see often rate of change is just rise over run. And those become the biggest words right there. So rise over run, that is called your rate of change. And that will always calculate our slope. So this calculates our slope. And that's what we're after. We want to calculate our slope or our steepness, though we often use the word slope. And what is slope? Well, we say it's our rise over our run. And the only reason we do that is just so that we can compare things. We want to compare different parts. So it says for the following graph, calculate the slope of each section. And that's how you can look at it. It says rate of change, but you could just say calculate the slope of each section. And it's actually not too difficult. So let's take a look here. Do I have enough space? Oh yeah, I've got plenty of space. Okay, so for our first, and you can see they're always broken into chunks. So let's first write down what our chunks are. So this is chunk number 1. So that's all of this area. And then we have a chunk number 2. It's really obvious. That area. You go until something changes. So this is going, and oh, something changes happening right here. Okay, so then we got this section here. So we'll call that section 3. And it changes again, and we got this section here, which we'll call section 4. So there's going to be 4 sections that we're going to calculate the slopes for. And it's actually very simple. It's a very simple concept. We'll just do 1. So section 1. And we want to do our rise over our run. Oh, things are not working out for me here. So let's just do this. Rise over our run. And equals. So we look at this area. And you can usually look at the whole thing, or you can just look at parts of it. Let's look at the whole thing. In this whole area, how much have we risen? So we started here at 0, we've gone up to 4. So our rise is 4. And over that time, over this whole thing, how much time has passed? And this is this much time. So we would say 2. So it's 4 over 2, or you can reduce that to 2. So our slope or our steepness is 2. Now that's meaningless unless we can compare it to something else. So let's compare it to section 2. And what is the rise and the run in section 2? So let's take a look here. So section 2 starts here and it ends here. So how much have we risen? And the answer is obviously 0. We have gone up or down nothing. And it goes from 2 all the way to 5. So we've run around 3. So we've risen 0 and we've run 3. Now, 0 over 3 is like if you have $0 and you divide it into groups of 3, every group would get 0. So 0 over 3 is 0. So you can look at these and you can say, well, 2 is definitely a bigger number than 0. So section 1 is much steeper than section 2. But what about section 3? Maybe section 3 is going to be even steeper. So let's take a look at section 3. Section 3 starts here and goes all the way up to here. So we want to see, well, how much have we risen? How far up has this gone? So we're here at 4. We started at a height of 4, and then we go up to a height of 8. So from 4 to 8. So we've risen up a total of 4. Rise over run. So from 4 to 8, if you go from 4 all the way to 8, that total distance is 4. So we've risen up by 4. And how far have we run? Let's take a look here. So we started here at 5, and we keep going up and up and up till we hit 10. So 5 to 10. So what was our run from there? Well, the gap from 5 to 10 would be 5. Okay, so it's 4 over 5. So you can write that. Sometimes it's a little more difficult to see this. You could write 4 over 5 if you wanted to do some long division. 4 over 5, by the way, is the same thing if you doubled it. 4 doubled is 8, 5 doubled is 10. 8 over 10 is 0.8. So this is the same as 0.8. So 2 is still higher than 0.8. So if I had to rank them from the steepest to the least steep, I would say section 1 is the steepest, then section 3, and then lastly section 2. But we're not done. We need to take a look at section 4. So section 4, that looks actually very steep. Look at how quickly that shoots down here. Okay, so what is our rise? And this is very interesting because all the other times we've risen and we climbed up, and then we didn't do anything, and then we climbed up again. So we've only ever stood still or climbed up. But this time, our rise is going down. So we need to make sure we calculate that. So our rise in this section is from 8 all the way down to 0. So how much have we risen? Well, we've risen, we call that -8. The rise is 8, that total distance is 8, but it's heading down. So we need to write -8. So for section 4, we've got a rise, and we have a run, and our rise is -8. And then, how far have we run? So we start here at 10, and we go to 12. So a total run of 2. -8 over 2, which is -4. Now, we can compare a lot of things. So we can say that this right here, this one right here, even though it's negative, it's the most steep. The steepness is 4. It's a negative, meaning that we're heading down, but this right here is the most steep because 4 is a higher number than 2. So that is our most steep. And so that's why we do slope. We want to know When are things changing the fastest? Well, things are changing the fastest at 4. That's when things change the quickest. And then things change, the second quickest is at the beginning. So I don't know what this is, but maybe this is you at home and you're riding a bike. And so for the first, oh, it's in seconds. Wow. So for the first 2 seconds, you run away from your house. So you're 4 meters away from your house. And then you ran, I guess, pretty fast. So for the next 3 seconds, you didn't do any running. You just stood there. You caught your breath. And then from 5 to 10, for the next 5 seconds, you ran again. But you didn't run quite as fast as you did at the beginning. And then you saw a dog at 10 seconds, and a dog was chasing you. And so you ran the fastest, and you ran all the way back home. So this is the kind of thing where on a test or on an assignment, you're going to have to tell me which things are the most steep, like compare the steepness of things, but then also come up with some sort of story that would describe this. So I ran from home a little bit, then the distance away from home didn't change, so I must have caught my breath. I stopped, right? That's what that means, to stop. So you ran away from home, then you stopped, then you continued to run away from home, but not as fast, and then you saw a mouse, and the mouse was chasing you, and you ran because you're so scared of mice, you ran all the way back home, and you ran really, really fast. So keep in mind that that's what we're hoping for at the end of all this.